Very good morning, my dear student friends. Okay, we have been studying about control charts for attributes. So we are solving the numericals so that it will give us a clearer idea. At the same time, where all these control charts for the attributes can be applied. In fact, nobody says that you have to apply P chart, NP chart, C chart, U chart, C chart like that, or X bar chart, R chart. It is the decision maker who decides about it. Okay. So depending upon the requirement. That is the important part, in fact. Which chart is to be used, that is most important. In few of the examples we have seen the control charts for variables. It was almost straightforward because X bar value used to be given, range value used to be given, or something like that. Directly or indirectly we used to know. But in case of control charts for attributes, always there is going to be some confusion. That is what I have been telling. Okay, in place of NP chart, you can use P chart, no problem. But you cannot use P chart in case of C chart, or you cannot use NP chart in case of C chart. Okay? In case of between U and C chart, always the U chart can be used in lieu of C chart, but C chart cannot be used in place of U chart. It's just like that. So first we need to think, categorize which chart is to be used. Okay? So let us take up this example and then see. The number of students, please take down, the number of students failing in an university exam was analyzed college-wise. The count of failures (15 colleges) are as follows. So this is the college code. And number of failures. Second row is number of failures. Okay, college codes A, B, C, D, E, F, G, H, I, J, K, L, M, N, O. There are 15 colleges. College A, number of failures 6, B 12, C 10, D 10, E 11, F 13, G 37, H 31, I 33, J 38, K 10, L 11, M 12, N 10, and O9. Got this one? So there are 15 colleges with this code number, and number of failures in the university examinations have been given. Now the question that is asked is, analyze the data through an appropriate control chart and check whether there is a assignable cause. Full point. Suggest the suitable average values for the next period. Okay. So now the question is, which chart is to be used? Okay. Which chart is to be used? So you start thinking, you should get a doubt whether I should go for NP chart or P chart or C chart or U chart. Here it will boil us down to these two things, whether NP chart or C chart. Somehow you just try to think. You will never think about P chart. So no other things are given, sample size and other things are not given here. Try to understand. Here, these things are not given. When the sample size itself is not given, that one clue I am going to give you. Sample size is almost because college code, college 1, college 2, college 3. This college 1 as a whole, it will be considered. Just like I was telling you, one particular big casting, and in big casting, there are number of defects. So this number of failures, they are synonymous with the defects. Got this point? That is how we need to think. So this will also tell us, even though the title of the course is Statistics for Manufacturing, but here what we are trying to do is, we are trying to apply it to service sector. Well, this education is a service sector. Okay, somebody might be viewing it as an industry also, but it should not be thought in that direction. Because why we say it is service sector, the active people are involved. Okay? Whereas in case of manufacturing, the items, they will be inert one. They will not exercise their thinking or what is happening to them. Whereas in service, always the customer is involved. Look at this example, tells us also how effectively these control charts can be used. That is what I was telling. Maybe in industry also, rate of absenteeism or the number of the workers or the people, they remain absent. On that one also, we can keep the watch. Okay? So mostly it is the control charts for attributes. So there is no, and one more thing, it says number of or the count of failures. Oh, that is what I told you. Count of failures, it is a defect. Okay? So this is a good candidate for the C chart. Then you might think whether U chart or C chart. Try to understand. U chart or C chart. Okay. Now, here the sample, whatever it is there, if it is varying, that means, say for example, college A has got some 500 students, college B has got 700 students, college C has got 800 students, like that, then the things would have been different. But what we are going to assume here is the strength of each college, or the students appearing for the examinations from each college, it is almost same. It doesn't differ. Otherwise, these values will not have any significance. This is what we need to analyze. Okay? Because here you can observe that, especially the code, college code with G, H, I, J, all of them, they have got one peculiarity. They together, they will constitute the major failure rate shown here. If you look at it, 1, 2, 3, 4. Okay? Because if we try to find out what are the total number of failures, if you look at that, then it gives us the thing. If we look from that point of view, let me see the calculated values. So if you add up the total number of failures, how much it works out to be? If we add up 6 this time plus 12 plus 10, that means sigma failures it works out to be 253. Okay? Now, out of 253, 37, 31, 33, 38, so almost around 130, okay, around more than 50% are contributed from these 4 colleges. Try to understand this. The other colleges are different. That at the outset, that is what it tells. Now what we have found out, total number of failures is 2. That is, we are just analyzing 253. Out of this one, only 4 colleges, they are contributing G, H, I and J. They together, this is 120, 120, 131, 132, 139. Out of 253, 139. This is the contribution from more than 50, nearly around 60% will be contributed only by these colleges. That means there is something wrong. That is what at the outset it says. But we cannot say with proper, this is at the outset, we can make a remark. Yes, it is almost true. That is what we can use it, that is Pareto analysis or whatever it is. It is very true. Others are 11, 12, 10, 6, 9, like that. They are varying. That variation might be allowed. But here what we need to find out, what is the maximum variation one can tolerate? And I told you one assumption we are going to make. The students appearing for the examination from each college is almost same. Okay? So the sample size, it remains constant. Because what we are trying to find out is, per unit, per college, what should be the average value per college? That means total number of colleges are 15. Hence, I am going to here number of counts, failures, or it is number of defects. Okay. Hence, we are going to use the C chart. Okay. So that C chart, then average value of C bar is to be found out. That is equal to total number of failures divided by number of colleges. Number of colleges are 15, hence 253 divided by 15. So it works out to be around 16.86. The average C bar value is 16.86. Okay. Now we need to find out, this is the average value. Now we need to find out what is the upper control limit and lower control limit. Having identified that the C chart is to be used, then we know that upper control limit for C chart is C bar plus 3 sigma C bar. Central line is equal to C bar, and lower control limit is C bar minus 3 under root C bar. Okay, we are going to use the 3 sigma control limits for the reasons I had explained in the previous classes. Because if we widen the control limits, type 1 error decreases, but type 2 error increases. If I widen or if I reduce the control limits, then the other way round will happen. Hence, the happy thing is between 3 sigma limit, it gives a particular thing. So hence, we are going to use 3 sigma limit. So here we have found out this one, that means 16.86 plus 3 square root of 16.86. This might work out to be almost 4, 12, that is what it works out to be, around 28 or something like that, or actually it works out to be 29.17. This works out to be 29.17. Okay, and this one 16.86 plus 3 under root 16.86. So this works out to be something around 4.54. 4.54, and the central line is 16.86. Now these values, they should fall within within 29 and 4, not 5 here, I am not considering. 4 and 29. Okay. So if we observe here 6, 12, 10, 10, 11, 13, 10, 11, 12, 10, 0, 9, all are within 29 and 4.5, 29 and 4. Whereas these 4 values, G, H, I, J, they are crossing that limit. Again, the process is same. That is what I told you. Again, if you have to draw the plot, the control chart, that means here is the sample size, 1, 2, 3, up to 15. And here this is the value of C. Here the central line, somewhere 16, I can put it here. 16, C bar is equal to 16.86, and the upper control limit is around 29.4. This is somewhere here. Upper control limit 29.17, and the lower control limit is somewhere here. This is going to be 4.54. So we can go on plotting, say for example, first one, 6, somewhere here, 2, like that. But when you come to G, it crosses the limit. Okay? Likewise, G in the sense 1, 2, 3, 4, 5, 6, 7, 7, 8, 9, 10, like that. 7, 8, 9, 10, all it crosses the limit, they crosses the limit. Hence, the process is not under control. But what is the practical interpretation of that? In other colleges, it is acceptable. That means we cannot assign any reasons or any reason for other colleges. But whereas definitely we can assign reason for these 4 colleges, namely H, G, H, I, and J. Maybe there might be shortage of qualified teachers, maybe one of the main basic reasons, or infrastructure or whatever it is. So this is what it says, so it is out of control, so there is an assignable cause for which one, so the adequate these things are to be considered. That is why always, whenever college is to be compared, it compares with the university standard. So university, it will have its own standard. Again, the other universities. Okay, now we have answered only because what we have done, we have identified correctly the chart, control chart. We have found out the control limits, and we have plotted also, and we have identified the colleges, okay, defective colleges or whatever we can say. And now in the subsequent or in the next period, what should be the control limits? That is what it says. Whether we should consider 16.86 only, what is to be done? Try to recall what we used to do in case of control charts for variables. There, out of control limits values we used to eliminate, and afterwards revised control limits used to be found out. Here also we can say that these are nothing but the trial control limits. That is what I had talked about in the previous class. These are the trial control limits. And we have found these things are to be eliminated. So we are going to eliminate and try to find out the fresh values. Okay? So that means now fresh values are going to be how much? 253. Now the number of failures will be how much? 253 minus 37 minus 31 minus 33 minus 38. Or if I look at this one, 9. So 253 minus 139, 4 colleges, that means 15 minus 4. So this works out to be 6114. Divided by 11. So this will become closer to around 10 point something. This is what it is going to become. So it works out to be 10.36. Okay. 10.36. Now this is the C bar, revised C bar. Now upper control limit we are going to find out for this. That means 10.36 plus or plus under root C bar. So even if we consider it approximately this system, that means it is 3 something. The square root of 10 approximately 3 point something. So it is going to be something around the upper control limit. If we calculate, it is something around, it works out to be 20 upper control limit. (10.36) plus 3, 10.36. This works out to be something around 20 point something. Lower control limit, central line 10.36. Lower control limit, this is 10.36 minus something around 9 or something around 10 of the 9. So it might work out to be some 1 point something. Okay. So upper control limit is the 20.01 and lower control limit it works out to be 0.07. 0.7. So virtually it is 20. Maximum number of failures allowed will be 20 and minimum is 0.7 or it is going to be 0. Whereas all these values they are between that. Hence, in the future, all the things are under control. All these things with revised these things average, because we will calculate on an average what should be the value, the process average. It has to be that much. So we know that is what it does. It should be hovering around that. And allowed so much, 21 point some 20 point something. That means maximum number of failures will be 20, minimum will be 0. Is it understood? So it will tell us how to identify these things. Okay. We'll take up some more examples and we need to decide which control chart is to be used, how, and other things. Okay, we'll take up some other example. Take down this particular problem. Following table refers to the average number of outlet leaks for 10 lots of 100 radiator each. Establish the control limits for the appropriate control chart for the future production. So now are lot number, number of leaks. many lots are there? There are 10 lots. Okay, 1, 2, 3, 5, 2. So, lot number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, first lot 15, 17, 12, 15, 17, 12, 16, 14, 5, 16, 14, 5, 14, 11, 9, and 10. I'll read the problem once again. Following table refers to the average number of outlet leaks for 10 lots of 100 radiator each. So what are these things? This is not for radiator. Try to understand. What this one? This is not for these things. This is what is to be understood. Okay? Now, how do you find out? What you will do? Which is going to be the appropriate control chart? Now, one thing we can say is, because certain things, what happens? It is very difficult to assimilate the things. Now, try to understand this one. It becomes difficult to assimilate the things because we are going to deal here with certain fractions. Unlike the previous example, we knew the number of defects. So here, since the lot size, it remains fixed, we could use even C chart. There won't be any difference at all. You can use either C chart or U chart. Why? The sample size is fixed. What is the sample size here? Can you tell? Yes. The sample size is 100. Sample size N is equal to 100. Because out of 100, if you look at it, 15 leaks are found. But which radiator? We don't know. Whether only one radiator has 15 leaks. Try to understand these things because these are going to be some practical problems. Because whenever we constitute, because this problem has been given, that is why I am trying to analyze that problem. You will take a lot of 100, out of 100, you will find out that number of leaks are 15. What does it mean? In one radiator itself, out of 100, one radiator, it has got the maximum number of leaks. Then what is to be done? That is the problem. However, we go along with this problem. Okay, this is going to be the problem. Precisely is going to be the problem. And if we go in terms of fractions, I don't understand. Again, it boils down to the same. You can see. So either C chart or U chart can be used. If we use U chart, how we are going to find out the control limits. And if it is C chart, how it will be. Because try to understand here, the sample size is fixed because the lot will consist of always the 100. It is not varying. Okay, the people can apply both. That is what I told you. Here you can apply either U chart or C chart. U is universal chart. Even in the previous example, we could have done like that. Okay, but since it was same, we are doing like that. So we'll solve this one by U chart as well as C chart, and if you compare both of them, the inference whatever we are going to draw, it should be same. There should not be any difference. That means on U chart it falls within the control limit, and on C chart it should not fall outside the control limit. It has to be same. Is it understood? Because that is what I mean by learning. Okay, just like that, we should not accept it. Okay. Now, that means what I have to find out. Now, if I decide, because either C chart or U chart, so let me say that I am going to use U chart. U chart means per unit. Per unit in the sense, this lot number 1, how many units are there? 100. Lot number 2, 100. This thing. That means per unit how much it is. That is what we can find out. That is what we say the U value. U value is equal to dn, whatever it is, number n is number of leaks. Okay. So this is number of leaks divided by the sample size is 100. That is 15 by 100. That is 0.15. This is 0.17, 0.12 like that. 0.16, 0.14, 0.05, 0.14, 0.11, 0.09, and 0.10. Okay, U bar is how much? U bar means summation of these things. 0.15, 0.17, 0.12, 0.16 divided by how many lots? There are 10. So divided by 10. That is what it should work out to be. So if I find out their sum, it is going to be 1. So this is going to be 1.23. So how many lots? 10. So U bar is equal to, this is how we need to calculate. This is going to be 0.123. This is on an average, there has to be 0.123 leaks per radiator. What it does, it says. Okay. So sometimes that is why sometimes the statistic is a funny thing. Okay. 0.123. So upper control limit is UCLU U bar plus 3 sigma limit U bar by n, where n is the sample size. The sample size is 100. So this works out to be 0.228 and lower control center line u bar, lower control limit u bar minus 3 underscore u bar by n. This works out to be 0.018. Is it understood? 0.018. Now, if we compare, these are, nothing is crossing 0.228. So the process is under control. There is no need to worry about it. Okay, in the future, we are going to continue with the same things. So per unit, we have found out. So by using U bar, U chart. Suppose if I use C chart. So again, what is that we are going to find out? Again, what we are going to find out? How do you do this one? These are per unit. So next time in the subsequent, we will take again a sample of 100 radiators, and we will find out how many leakages are there, number of leaks out of 100. Okay, suppose I find 10. That means it is going to be 0.1, which is lesser than 0.228. Yes, again it is within control limit. Suppose if it works out to be around 25 leaks, then it goes out of control limit. That means 25 divided by 100, it will be 0.25. Try to understand this way. This is how it should go on. Okay. Now, the another this thing is, if we look at, because it should not give the correct picture, but in any case, if we apply the practical way, what do you expect? Any radiator? Well, I am now discussing about practical application of this. There should not be any leakage, is it not? Because it says per unit 0.123 average. Means what? 0, because 0.123 leakage I cannot find out. There should not be any leakage at all. But about the process, if you find some radiators are leaking, in the sense up to 20, which will have only one leak, something like that, we can allow. Okay, but practically nothing, no radiator should have the leakage. Try to understand, putting it in that way. Suppose if I want to solve it now by C chart. Okay, how do we go about it? C chart. What we'll do? We'll just try to find out what are going to be the number of leakages. Okay, total number of leakages. That means 15 plus 17 plus 12 plus 16 plus 14 plus 5 plus 14 plus 11 plus 9 plus 10, like that. So how much it works out to be? 123. Okay. So 123. Because just see how it gives a realistic picture. Total number of leakages will be 123, because this one, if I add up 9, 10, 15, 20, 24, 30, 32, 39, 123. Okay, and how many these things are there? The total number of decays are 123. So what is the sample size? The sample size is fixed. It is fixed as 100. So this one will be divided by 100. So this works out to be 1.23 C bar. C bar works out to be 1.23. If you calculate the upper control limit here, now what is going to happen? This will not be U bar by N, C bar by N, no. Now what is that? Under root. That means upper control limit 1.23 plus 3 under root 1.23. So under root 0.123, let us find out. .109. So this is 1.23 plus 3.327 plus 1.23 is equals to 4.57. 4.55. Okay. Lower control limit 1.23 minus 3.327. This is equal to 0. What is going to happen now? Okay. Sorry, I made a mistake. Okay, there is a mistake here. It is not 100. It is going to be 10. 12.3. C bar is, sorry, I made a mistake. 12.3. So upper control limit 12.3 plus 3 square root of 12.3. This works out to be 3.507. 12.3 plus 3 3 into 3.507, that is 10.52. 12.3 plus 10.52. Okay, so this works out to be 10.52 plus 12.3, 22.82. 22.82. Lower control limit 12.3 minus 10.52. This is 1.78. Something 10.52. Okay. Okay. So almost it works out to be same. You just observe over here. Now this is 2.22.82. That means if you multiply it by 100, we are going to get the same thing, whatever I got there. Try to understand the beauty of this one. That means C chart I am going to use. What has happened? The upper control limit is going to be 22.82. That means maximum number of leaks allowed in a lot of 100 can be up to 22. So nothing is falling outside the control limit. And minimum number allowed is 1. So nothing is, so there is no 0, because if something somewhere 0, then there would have been cause for worry, because we need to stop and try to find out the reason, even though the quality wise it is beneficial to us, but we need to find out why we are producing very good items. Can you assign some reasons to those things? That is how it goes on. So it becomes easier for us for convincing. Take a lot of 100, in future this thing, what is to be done? Average value is going to be 12.3, that means average value is 12. Maximum allowed this thing is 22. Minimum allowed is 1. As simple as that. Take that one, find out. Then you can be able to say whether it is within the control limit or not. So friends, I had taught you, you can use here in this particular example, you can use U chart as well as C chart. So the inference is going to be same, not much difference. But let me see whether I can take up some problem, because in that case really n should be varying. Here the n is fixed, that is why we are unable to understand this U chart. Okay. Likewise P also we have seen, if it is variable then we can find. That means here also for U chart it will have the upper and lower control limits they are going to be variable. But one thing you need to clearly understand, U chart it follows the normal distribution, whereas C chart it follows the Poisson distribution. If the probabilities are to be found out, then different probability distributions are to be used for both the cases. So in subsequent class or the tomorrow's class we'll see if probability limits, what do you mean by probability limits, and if the probability limits are given, how to go about it. Okay, thank you. I'll be stopping at this point of time.